We're going to quickly switch to Jasper Oslevier, who's going to talk about expanding the reach of formal. I think you've got the right slide.
Yeah, I think it's the right thing. So in the 20 minutes that I have, what I'd like to take the opportunity to introduce Jasper to you. I don't have enough time to really speak to you about the breadth of our technology or everything that we do. So what I chose to do is to present Jasper to you from a business perspective and from what is the difference between Jasper as a company and other small EDA companies. I do want to talk to you about our strategy and our methodology for driving our success, because it is very different than other small EDA companies, and it is fundamental to where we are today and how we're able to bring value to our customers. I'll switch then to talk about one specific value solution that we bring to customers today around coverage. It's one of our apps, the Design Coverage app. And then I'll want to talk to you about what we see as the future of formal and how you are going to benefit from it, how it's going to impact you. Jasper today is the most successful and the best private EDA company in existence. Taking in any measurement together, but some of them even alone, Jasper is doing very well in terms of growth, in terms of renewal, in terms of its customer base, and in terms of profitability. The company has been growing tremendously fast on the basis of interaction with our customers and on the basis of success with our technology. Most important, we've been profitable for 3.5 years. So the company has been able to plow back all of the success that we've had into additional technology, additional solutions for the benefit of everybody. I want to look at some specific measurements to show you why we think this is really important to be a big company, to be a growing company. Since 2010, Jasper, on a compound annual growth rate, have been growing its revenue almost by 40%. Just to understand what that means, it's almost doubling revenue every 2.5 years. In EDA, that's unusual. Maybe in social media, that's more common, but in EDA, that's unusual. But let's look at some other measurement around it. The number of licenses that are deployed in the field of Jasper solution has been more than doubling over the last 4 years, every year, more than doubling. 129, almost 130% growth every year. While our revenue has only been growing only by 37% annually on average. What that means is that our users are able to get much higher leverage on the dollars that they're spending with us over that period. In a way, we are enabling wider deployment for a much lower price than in initial deployment. Another measurement is that our revenue on an annual average is growing faster than the number of users that we have. Now, what does that mean? It means that our strategy has not been to logo hunt. We don't have many customers. As a matter of fact, I can share with you, we only have about 25 customers. But our strategy is to make these customers very successful. And the success comes in terms of wider investment in specific accounts to grow the deployment as much as possible. We don't try to hunt as many logos. We don't try to get small deals all over the world. We try to focus on accounts that made commitments to us and grow the deployments as much as possible in these particular accounts. The last one is also very interesting. The number of individual users that are registered on our support website, on Formal Expert, has been almost doubling every year. But the number of licenses, as we already discussed, is more than doubling every year. What does that mean? It means that parallelism, either with Proofgrid or with multiple licenses on multiple machines, is growing faster, enabling better ROI for the specific users that are growing with us. Now, it's easy to throw numbers and percentages around, especially on revenue, without giving you a basis. Just to set the base here, Jasper today, revenue perspective, is above 25 million annual revenue. So we are not only a growing company, but we're becoming a big company in terms of what a small company can achieve. How did we get there? The reason Jasper is able to achieve this kind of level of success is because our strategy is different than other formal companies have been in the last 10 or 12 years. Everybody that have touched formal in the past, be it Synopsys or other of our competitors in Cadence, have always accepted the limitations of formal as too small, too difficult, too hard to scale, need a PhD. Jasper never accepted this limitation. Jasper has always believed that the right approach is to scale formal to fit the problem. So today we have applications in formal that are able to handle a complete SOC in excess of 100 million gates equivalents. We have designs that can handle difficult problems such as deadlock detection, cache coherency, sequential equivalency at the SOC level, and more and more and more. We are employing parallelism. We're employing different engines, more than a dozen proof engines. In short, there has never been the idea or the thinking that formal is limited. There's always been the belief that formal can scale. And with a scale comes solution. And with solution comes success. Our strategy around the products is to create multiple offerings that fit different types of problems. Started with the formal property verification app, which is better known as Jasper Gold or the proof engines, allowing some other solutions in terms of connectivity, X-propagation, control and status registers, and then migrating over the last 3 to 4 years into more difficult areas like low power verification, sequential equivalency checking, security, and other areas, including post-silicon debug. But today, what I'd like to talk about is about coverage. Yesterday, we talked about security. If you're interested in that, the slides are going to be available on the TVS website. And I have, like 25, 30 minutes left? Something like that nature, yeah. About 10, okay, same thing. Yeah. Never accept the limitation. So, what is our coverage philosophy? I think I can divide our approach to how to deal with coverage into two separate aspects. The first one is in integration and support of simulation or external coverage information, be it UCIS or UCDB or any other source of coverage information. And the second one is to provide coverage matrix specifically for formal verification. So I stepped a little bit too far. Let's talk about the first one. The idea there is, again, two-headed, two main values. First, we believe that by bringing in information about coverage from the simulation or from the emulator or from whatever other source of coverage that you have, we can help you achieve two values. One, can lower the denominator. Formal is extremely proficient at finding unreachable code or code that is dead, and therefore eliminating the need for this coverage. But the second value is that formal is extremely powerful, especially Jasper formal, extremely powerful at closing verification holes. How? If you have a corner case, if you have something that is very difficult to reach with constrained random, an assertion can always become very useful, or a property. a property that is targeted in a specific area or state space or a statement, and be proven, and then eliminate the need to run additional simulation. The area that I'd like to focus now is more on the formal coverage. And the reason I'm doing this is because, frankly, we don't have a lot to show for in terms of simulation integration. This is something I'd like to ask for maybe help from some of the user community. We need the users to step up and help us motivate some of the simulation vendors to do some integration. It's not enough to support UCIS. What's really important is to get the simulation vendors and the formal vendors like us to agree on the coverage semantics. And this is something that we've had some trouble getting started, specifically because there isn't a whole lot of grassroots support from the user community. So if you believe it's something important, talk to us and talk to your simulation supplier. Tell them, we would like to see coverage between Jasper or between formal and the simulator integrated. And we would like to see it now. We're ready to do this. What are we doing with formal specific coverage? Again, two very different value propositions that are supporting each other. The first one, and this is something that is very rarely done in other verification methodologies, is to use the coverage technology to qualify the soundness and the completeness of the formal test bench. The formal test bench, maybe test bench is a misnomer, but the formal environment is made up, to simplify, is made up of properties and constraints. But you can write properties and constraints to kingdom come. You need some understanding of knowing what exactly is the goodness. How good is it? How complete it is? So that's the first value that we are focusing on, is stimuli coverage or the appropriateness of the constraint, and property completeness, to see how well does the property cover not just the code, but the state space. The second one is to measure the verification impact of the proofs. You run properties, and the engine's charged, and you spent it overnight, and you got convergence or some bounded proofs. What does that mean? So the idea is to use this information to qualify the test bench, and also to qualify your efforts, to give you some measurement of how far have you gotten with your verification effort. Not sure how much more to spend time on this particular. The application itself, the app, is very simple. Start with the RTL, with the assertions and the constraint. You shove it into the app. Some stuff happens and a report comes out. It's not that complicated. But with the property completeness, what is important to understand is that you have multiple properties. Actually, here only about 4 of them, but each one of them have a cone of influence. I want to emphasize that the cone of influence is not just lines of code. It's a state space cone of influence. In other words, it's the entire state space of the design that is covered or potentially covered by this property. The way to understand this is, if this property is proven under these set of constraints, then this entire code of influence is covered, considered good, appropriate. But obviously you can find a situation where there are cover items or even entire lines of code or partial statements or branches that are outside of all the code of influence. In a report format, they could look something like that, where you could see that specific lines or specific areas of your design, or in a partial way, some value composition of these specific lines of code is outside of the cone of influence of some specific cover targets. And then it's really your task to figure out, how do I extend my property set to include these items, or do I exempt them from the coverage. So it's very easy to understand how complete proofs figure into the coverage. If the proof is converged, you don't have any questions anymore. You have the entire state space is covered. All of the cover items under it are 100% checked. You're done. But what if you got a bounded proof? How many people know what a bounded proof is? It's a proof that the tool can guarantee that is correct, but up to a certain cycle depth, maybe 30, maybe 100, maybe 200. And usually a bounded proof comes about because the property is very complex, or the state space is so big that it just takes too much time to go through and advance the proof bound by another cycle, by another cycle, by another cycle, by another cycle. What you want to know is how close is the bound to the theoretical need of that particular state space. So the formal tool can tell you these two pieces of information, that on one hand, your bound proof is a certain number, let's say 10, 25, it's a number of cycles. But you really, for hitting these particular state space variables, it needs 31 cycles, or 40 cycles, or 100 cycles. Now this is more empirical. This is not a black and white yes or no. But it gives you a much better level of confidence if these numbers are close together to one another. What can you do? The one thing you can do is agree that this is done. Another thing you can do is to start inserting helper assertions, or try to use different engines in order to try formal engines to bring about convergence. This is probably a deeper area than I can cover in the 35 minutes that I have left. So, you know, I will not go through this entire slide. This app for us is relatively new. It's been around for about a year. It's not in wide deployment. It's with advanced customers, but it's already proving its measure and its ability to bring value with specific advanced situations. So I want to close and really in the last 2 minutes maybe talk about what I think this is going to mean for all of us together. And one other observation is that if you look at formal today, Jasper is scaling much faster than Moore's Law. You know, the original Moore's Law was doubling every 2 years. Somebody later changed it to doubling every 18 months. But this is the compound average growth of 42%. If you look at the capacity, this is just one measurement. There's also performance. There's also lots of other measurements of the improvement in formal. But just in the capacity, you know, we are doubling every year since 2004. So whereas in the past, formal was thought to be small and difficult, today it's broad, it's wide, it's relatively applicable to very large designs, including SOCs. And in many cases, it's easy to use. It's easy to use because there's a lot of automation. What will it mean to you in the future? Our prediction is that formal is going to be the default choice for many verification tasks. We think that simulation will very well become more of a niche solution, more of a special case. We think that the force of growth that we are experiencing is inevitable. And eventually, formal is going to be a dominant force in verification and in design. You know, this is our prediction from Catherine, our CEO, in the last jug. And it's not next year, but over the next 5, maybe 10 years, maybe 15 years, I believe it will become true. Thank you.
Thanks, Josh.